Okay, so now basically they're talking about the design, okay, the amplifier using the bipolar transistor, NPN, PNP. And in order to do, you have to understand that we get a two different part. One we're talking about DC bias. The other one will be the AC. That means what the amplifier tries to amplify. They amplify your voice, the sine wave input, okay? However, they need a DC power supply to the circuitry to make sure the transistor working before transistor can be using at the amplifier. So if you want to go to the college university, that is the one you need to get through. The thing that they will be doing up there, like design amplifier. First thing is you want to amplify analysis, then you have to done for the DC analysis. That means all of the calculation for DC must be done. If it's not working, then you cannot doing any amplifier. Then you have to sort on coupling by path capacitor, and you visualize on DC supply voltage at the AC route. So you cannot see any power supply in the AC, and you replace the transistor by the pi or the D module. And then you draw the AC equivalent. That's what I showed you here. So basically, you can see the transistor you write normally this is a transistor. However, if you want to doing for the amplifier, they convert to the AC. And now they will be look like this one right here. This is the collector, this is the base, and this is the ammeter. And very important to you. If you're looking on the DC between the base and the ammeter, you get a diode. However, for AC, you don't have any more diode. And substitute by the resistance R prime E. And we already telling you R prime E equal 25 millivolt divide IE DC current. Okay? And now, if I say I want VB, when I talking about VB, you must be understanding the voltage will be measured from the base.
Hello?
Somebody's receiving a FaceTime call in the middle of our Zoom session.
Tôi đang ok, tôi đang dậy tới 7 giờ tôi mới hết. Ok. Rồi, ok, rồi. Okay. So if I say I want VB, if the voltage VB, that means you measure from the base to the route. VC means from C to the route. Or VE, that means from ammeter to the route. Okay? And now if I say I want the resistance from the base, V input resistance, okay, in R in base, then that will be measured from the base to the route, okay? Let's try to explain to you. Normally for the voltage divider, normally you calculate the voltage at the base, you take the VCC times R2 divide R1 plus R2. However, if you're looking on that circuitry, okay, let's see, I can get that circuitry right here. If they want the voltage here, then normally I am telling you to take a VCC times R2 divide R1 plus R2. However, sometimes you must be pay attention at the base to the round to still get the resistance. That will be called R in base right here. So R in base, and they will be on in parallel with R2. So that's why you have to combine R in base and R2 to get a one resistor. Then you can apply VCC times that total resistance here, okay, and divide by R1 plus R in, okay. But normally R in base will be 10 times bigger than R2. So that's why we ignore, okay. And then in here, you understand the basic definition for the gain, just V out divide to V in. Okay, now this is a common admitter, and only thing I want you, when you're looking into the circuitry, you know that will be common admitter. Okay, and also you have to telling me input here and the output here, they will be opposite 180 degrees out of phase. That is what the technician you must know. Okay. And also at this point right here, at the base, you get two signals, not one. One sideways and one 1.8 volt DC. So if you want to measure this sideways here, your oscilloscope must be set to AC coupling. So you cannot see any DC voltage. Otherwise, you cannot measure. The thing is, this sideways here, 100 microvolt compared to 1.8 volt DC. So they will be look like, burning side that 1.8 volt. So they must be AC coupling. Also at this point right here, you get a 6.04 volt DC and also the sideway. The sideway will be small compared to this DC. So you want to measure right here. Voltage peak to peak, you must set AC coupling. However, when they go to the output here, you can see right now the zero. Right here, that's 6.04. So that is the blocking 6.04 volt going out. You get only sideway. Then you can set AC/DC, that doesn't matter. Okay? And also, C1, C2, blocking AC, coupling DC, blocking. C3, bypass. Without bypass, the gain of the amplifier will be lower. Okay? They need the bypass to make the gain higher. And basically, the people not quite follow, understand. I said this right here, VB, and this will be V in, and this will be V out. Can you tell me what the gain for the transistor? AV equal what? The ratio between which one?
VB over V out?
No, that the gain have to be V out over. Right?
V in. V out or V in.
Okay, that's
V out over V in.
okay. You say V out over V in, right?
Right.
No, sir.
Gain of capacitor C3.
Now, nothing to do with the capacitor.
V out over VB.
Exactly. That is what I want to make sure you understand. The gain of the transistor amplified, they have to be V out over VB. Not V in. Can you follow that?
Is that because of the capacitor or what?
No, not
No,
to do
no,
with capacitor. AV,
It won't,
AV,
it won't be negative V out over VB for
But-
common amplifier.
they must be
Common,
V out over VB. Okay, now, in this case, V in equal VB, right? That is shorted. So the V in here or VB here will be the same. You see that? So that's why sometimes they say, okay, in that case, VAV equal V out over V in. The reason is V in and VB the same. You get that?
Mr. Pham, are you saying that that the gain is actually V out over VB, but since VN is equal to VB, that's why we use V out over VN?
Right, in this case. But basically, definition, they have to be V out over VB. Now, I given you an example. There's a generator if they get a resistor here. And for example. So they're telling you VB or VE not the same. Continue to get a resistor right here.
That's like an internal resistance, correct?
Doesn't matter. That means they given you the resistor for the source. That's only telling you VB and VIN, they not the same. You get that? Yeah, any confusing, just bring it up to make it clear.
Well, what does the RS do? What exactly
No,
does
it
it?
doesn't matter. They get the output resistance for the source. You don't care what they doing, but you care they get a resistor there. And that's only telling you what? VB and VE not the same. The thing is they get a difference on the RS. If you don't have a RS, the capacitor just shorted, and V in or VB just a 1 volt. But now you get the RS, only telling me V in and VB not the same.
Well, let me ask you this: if you
Yeah,
put
go ahead.
if you put RS in there, then the gain would be different, wouldn't it? Because you said VN and VB is different.
Yeah, V in, that's the only thing I want you to know. V in and VB not the same.
When RS is in there.
Right.
But if RS is not in there, then they're the same.
Yeah. Capacitor just shorted like the wire. So the V in or VB, that's just a 1 volt. Same thing.
Joseph, if I may, Mr. Pham, if I may interject, that what you need to understand is that any real world voltage source has an internal resistance. So there's a little bit of voltage dropped across that internal resistance. So you need to account for that. Remember way back when we talked about a Thevenin equivalent circuit, and that sort of models that series internal resistance.
Yeah, they internal or not. Normally, they draw RF for you to telling you the difference between V in and VB. I given to you that part right here. Okay. Last time we already done. Right here. You can see that. I try to delete that one first. You can see right here. That is the RF resistor. So now you can see this is a VB right here. This is a VS or V in right here. So V in and a V, they're not the same. Don't worry about RS. If you see the RS up there, so the formula I telling you the gain for the transistor here, AV of the amplifier transistor, they have to be V out over VB, not V in. They only up to here. And now, if you want a VAV total, they will be, you can see that right here, VB, and you get a 600 here, and also you get a resistance right here. Whatever resistance here, okay? Like G in base. Then you have to doing a voltage divider. Take the gain here, time to that one, divide by a total here, okay? In order to get the total gain. So that when.
Hey, Mr. Pham, you were explaining something, but you weren't using your pointer, so we don't know what you're talking about. Could you go back and use your pointer?
You mean here, right?
Yeah, whatever you're doing, use that pointer so we can see what you're doing.
Okay, what I want to make sure you understand, when you calculate the gain for the transistor here, they will be a V out divided to VB, not V here. Okay? Only thing if you don't have a this resistor here, then okay, they can be V out divided to a VS here. The thing is VS or VB will be the same. But if you get a resistor here, then they're not the same. You have to calculate the gain here, then using the voltage divider in order to get the gain for total gain. That on this one, they will be doing calculation for you.
Mr. Pham,
Yeah,
when you use a voltage divider, the gain that VB you get is DC, right?
you get VB here already.
Right, that's DC in DC.
That
not
means the gain right here ready. Right? you get the gain already right at this point.
The gain of voltage.
Gain
Okay, yeah, you get the gain.
right here. Now you
Right.
want to get the gain right here.
That's AV total.
Then you have to know what the resistance right here. Okay, so basically they have to draw this way. Easy for people understand. This will be S right here. And this will be V in right here. And this will be some resistance. We have to do calculation. You get the gain right this point right here. Okay, that means the AV1. And now you want to calculate the AV2 right here. AV total of AV2. Then you take the AV1 times that guy divided by a total. That will be including into the calculation for this circuitry. Last time we stopped at this point. Normally, they don't care this one. So that's why most of the amplifier you don't see are S. Okay, but sometimes some different textbook, they bring it up, then we have to know how to do calculation. Especially if you go to the college and a university, then you have to deal with that. Okay, we will be get up back to that. Okay, let's see where we are right now. Okay, this one here, no. Okay, last time we're here. Okay, so basically for me, okay, I just guarantee to make sure when you're looking into that, a very good picture for technician to review. Okay, looking into the circuitry, you know what the signal at a certain point supposed to be. Okay, is it a voltage DC or that will be a sine wave, peak to peak? And now, if you want more detail, then that's what you need to know at the collector, and you can get the RC in parallel, RC parallel RL. That means you want the output impedance looking from the output into the circuitry. They're telling me RCIL in parallel. Okay, and some data book they're using R small, C small. Some other one they can go R big R, C small. But normally I using Z out. Z out means output impedance. That only talking about the AC. Okay, and also you can see how many resistance in here on the amplifier. What they want the gain. They want the output impedance. They want the input impedance. Okay, that's the only thing they wanted. Okay, for the technician, we not go to the detailed calculation. If you can do it, that's good. However, if you want the gain, they already given to you. Okay, A equal R small c. That means Z out divide R by E. That
Hey,
one.
Mr. Pham, right before you leave that, just a question on the R small c. This is a question only. Is R small c, is it also sometimes called little r load, like little r and then LOAD?
Yeah, That means they get too many way, different book. Okay.
Okay, yeah. I just think I thought I saw it written as a little R and then load.
Right.
Okay, thank you.
The only thing we read it, we know what they're talking about. Okay. Some they're using capital C, lower K. That means output impedance. Okay, so this one here, we already done. Okay, and this still common at meter. Okay, and that will be a voltage divider. We already know that. And also they want you to calculate the R prime E, R in B, R in total, R out, output impedance, voltage gain of V out. Okay, and on this circuitry here, okay, only thing they bring it up is not by part. You can see they take out the bypass right here, okay? And they have to do calculation again. So without bypass, if you're doing a calculation, that's what they want in here. Then you can see the gain will be smaller, okay, lower. So that will be telling you how we did with no bypass, okay? And now another amplifier they call it SWAM amplifier. That means they're adding one more resistor here. And bypass capacitor here only bypass RE2, not bypass RE1. Okay. And also they put a RS equals 600 ohm here. Okay. So the complete calculation here, I already calculation for you for VB, VE, IE, IB, IC, VC, VCE, R prime E. Okay, on the AC calculation, and that will be telling you R in B will be equal beta times R prime E plus RE1. Okay, on of the calculation here, I hope I can get the answer for you. Now, it's not in here, but I will be giving to you the answer for your calculation. Or you can see it in the final test. Okay. So that is still swap. Okay. I don't know anyone do this calculation or not. Maybe not. The thing is go too much detail. Okay. We'll get answer for you. Okay. And another one quickly, CCMD5. They get another name, admitter follower. Collector is AC route. Stable voltage gain. High input impedance. Low distortion. So when I asking you the question in the quiz or in the test, they cover everything in the handout we already give it to you. Okay, like I say, for CCMD5, input impedance is low or high or whatever. They telling you right here, they get a high input impedance. Okay, and then they're telling you right here, the circuitry for common collector. So input go to the base. However, output from the collector. Okay, and the input output in phase. Okay, and they say right here, Input applied to the bay, output from the admitter, C1, C2, DC blocking. Input, output will be in phase. That summarize minimum thing. When you're looking into the circuitry, you can answer. And it will be telling you how you doing calculation are in bay, okay, are in total. And also output impedance. That means RE parallel with RF. AC voltage gain will be RE divided R prime E plus RE. And if you want to calculate the Vout, and AV will be time VE.
Hey, Mr. Pham, what was that deal with the RN base? One of them, they do the beta times the RE, and the other one leaves the R prime E out.
Which one? Here,
No, look at the formulas.
the formula
Yeah, RN base.
I in bed, beta time R prime E plus RE.
Why is it that one of them, they take the R prime E out?
Okay, let's see. I in bed and beta is getting. Okay, let's see. RE equal R big E.
No. You're looking at the wrong formula.
I try to see how come they remove that guy. That's what your question right here.
Yeah.
What I try to see. Okay.
Because R prime E is too small.
Okay.
Yeah, if the collector emitter current is high enough, then RE, R prime sub E is so small that it doesn't really make a big difference. So
Okay.
you can ignore it, right? You can ignore it.
Okay, gotcha.
Yeah, the thing is when you calculate either one, the answer will be almost the same.
Okay, gotcha. Thanks a lot, everybody.
R in total will be R1 parallel with R2 and parallel with R in base. Okay. R small, R big E small e output. That means output impedance. So they will be RE parallel with RL. AV voltage gain equal. Okay. And that's what the exercise for you to do it. Okay. And the common collector here. Last one, common base. Base at ground. Input drive admitter and the output taken from collector. No current gain, but has a high voltage gain, low input impedance, high output impedance. Okay, high frequency application. So when you look into the circuitry, you see the input now applied to the admitter and output from the collector. So you get a capacitor here connect from the base to the ground. That will be telling you AC, they will be ground. However, for the DC, they will be open. That's why you can get the DC voltage here. Okay, so the voltage gain equal RC divided R prime E parallel with R big E. Input resistance R in, R prime E parallel R big E. Output resistance RC RL parallel. C1, C2, DC blocking. Okay, and also they given to you the example here. Okay, I think in the past we already got through it. This is a Darlington connection. Only thing is, this is a one IC. One they put two transistor into the packet. That's what they call it. Darlington transistor manufactured with transistor in one case. Only one case here inside you. Data separately you can build easy. Okay. But the thing, only thing telling you, they want to increase more current gain. Current gain on the first one, beta 1. On the second one, beta 2. The total current gain will be beta 1 times beta 2. So you can see the current will be very, very high. Okay. Now, a certain cascade amplifier arrangement have following gain A1, V110, 15, 20. What is overall voltage gain? Also express its gain in decibel and the total gain. Okay, you already know to working on the quiz number 21. We already told you, and you will see again on the test. Okay, last one. This is a multi-stage amplifier. You get a one amplifier here, right? And the output go to the input of another amplifier. Okay, and in this circuitry will be a CE amplifier, common meter. And they given you beta DC AC, same thing, 150 for Q1 and Q2. Okay, and now let's see. For the multi-stage of the circuit, they want to VG1. If they want VG1 right here and a VG2 right here, that's easy for you to do, right? You can take the 10 volt times R2 divide R1 plus R2. The same thing here, okay? 10 volt times R6 divide R5 plus R6. Then they want VE1, IE1. If they want a voltage here, how? You already get the voltage here, right? VB1. If you want the VE1, then will be equal VB1 minus 0.7. Okay? VE1, VE1. After you get the VE1, they want current IE1. You take the voltage divide to R4. Okay? And this calculation will be the same thing on the second. Okay? And then now they say they want R in B2. Let's say R in B2 equal what?
What is the Mr. Pham, number 4?
Number 4. What number 4?
Oh no, R prime E, that's just 25 over,
Yeah, 25 millivolt
yeah, over RE. Okay.
by RE1. Okay. Now they're talking about R in, okay, B2. Right here, you can see that R in B2. That means they want the input impedance for the Q2. So they draw it for you right here. R3, where R3? That R3 right here. R3 parallel R5. That means R5 here, R6 here. When you draw for the AC, they will be go to the ground, right? So that's why R3 parallel R5 parallel R6 and parallel with R in B2. Let's see. R in B2, they calculate E equal 3.57 kilo ohm.
Where did that come from?
Okay, let's see. I remember I already did it somewhere.
That is beta times the R prime E.
R in B2. That
Yes. So your beta is 150 times the R prime, which is was 23.7 ohm.
R in B2, basically they will be, let's see, input resistance of second state. Okay, that means the input here. So, and basically they get this one, parallel this one, parallel this one, and now they want R in B, that means from here to the round also, right? That means R in B, they will be going from here to the round right here. And you know how to calculate the R in B from here to the round. We already get the formula.
Where's that?
I'm telling you.
Beta times RE prime.
Somehow. I think I already get the calculation. Okay.
Keep on going up a little bit more.
There it is right there. Whoa, whoa.
Right here, beta times, it should be just beta times RE prime for the,
Right.
Okay.
because you're going to have is just the RE, because then you got the capacitor to bypass the capital RE.
Okay. So basically, they will be one RC1 voltage gain of the first state, voltage gain of the second state, and the total. Okay. When I will give it to you and try to explain to you all of the calculation. Okay. But the thing is right now, we don't have enough time. We have to take the test right now. Otherwise, don't have time.
Sounds good.
So make sure you download your report. Okay, I run the test now. 20 seconds. Hopefully not run by the key.
Don't worry, Mr. Pham, I'm ready.
Quick 20 seconds. I guarantee I'm not get any answer arrow yet.
I'll let you know.
Okay. We're stuck now. Okay, that's it.
That's it. That's it.
Thank you.
You're welcome.
See you tomorrow.
Mr. Fan,
Yes, sir.
I sent a private mail to you. Do you get that email?
Not yet. I
It's in chat.
Oh,
I listed in chat.
see.
Look under your private. It's the original email from when I started class.
Okay, let's see.